Assalamualaikum everyone. I am Atik Mosher. My ID is 2434125. Today my presentation topic is unit which is a convolutional network for segmentation. At first we have to know about what does a unit do. Unit basically does segmentation. It divides the images into two parts. It takes the input image, learns segmentation, and then output segment the thing. How does it do it? Basically, it each pixel in the image would be classified as either the object or not object. For the example we are showing in our slideshow, the cat. In this picture, the each pixel will be classified as a cat or not cat. Unit will help you to outline the shape of the cat by providing a precise mask that will highlight the boundary. We can see it in the output segmentation map. We can even change the background or apply filters in the background or in the cat image. This is how unit do. Now we can talk about what is unit architecture. From the name, we can say that it is a U-shaped network. It is basically a encoder-decoder network which consists of four encoder-decoder blocks and four decoder blocks that connected via a bridge. It is consists of an encoder network which downsamples the input image and a decoder network which upsamples the encoded features. For example, in medical images, UNet can take a brain scan as input, analysis to locate as a tumor or brain hemorrhage, and produce an output image where the main thing is highlighted. This ability to separate and clearly mark different parts of an image makes unit so special. Now, we can talk about in which sectors unit is mainly using. At first, we can say about medical image analysis. In from CT scans or MRI scans, unit can detect disease, segment organs, identify tumors, or track diseases. Second, computer vision. In computer vision, we can detect, recognize objects, segment regions, tracks motion, or process 3D structures by using unit. In generative models, unit generates images, audios, or text that does not exist. It's a unique one. Now talk about anomaly detection. In anomaly detection, unit flags finds irregularities in images, financial transaction, manufacturing process, or network traffic. Also in time series forecasting, sentiment analysis, we can do it using unit architecture. Now we are seeing how unit architecture is look like. Unit architecture, we have previously said that it is a U-shaped architecture. We can see a input image style is given. In U-shaped it is processing and there is a layer. Then after it produces a segmentation map. Now we'll talk about more detailedly. The first part of a unit architecture is constructing the path. This constructing part is also known as encoder. This part is responsible for extracting features and reducing the spatial dimension of the input image. The goal of this path is to gather information about the image like edges, textures, and shape. Now we can talk about how this path works. This path at first takes the input image file we are seeing at first. Then the convolution it passed through the layers, the convolutional layers, and these layers will highlight the areas that representing the edge, the corners, and etc. After then, a railway activation function is applied in each convolution. This activation introduces non-linearity, allowing the network to learn more complex features. Also, it can do downsampling, progressive feature extension. That after doing the contracting part, it will reach in the down part, which is mainly known as bottleneck layer. Bottleneck layer is basically works as a bridge. It connects the encoder part and the decoder part of the unit architecture. This feature mainly focuses on high leveling features of image without worrying about its size or fine details. Now we can talk about how bottleneck layer works. As the input, the bottleneck layer receives a highly downsampled compressed version of the input image from the contracting part. Then a set of convolutional layer is applied to extract deeper, more complex pattern from the data. This layer allows network to learn relationships between high-level features and the organ types or distribution tumor region. But unlike the construction part, bottleneck layer has no downsampling. It is basically work as a bridge between it. Now we know why bridge is important, why bottleneck layer is important, because it ensures the later part, means the decoder part, is receiving the right information to reveal the image combining global context. Now we are going to the last part of the unit architecture, the expansive part or the decoder part. Decoder part is mainly the constructing part, different mainly divided the images into part, and the decoder part is will add this picture and reconstructing the image into original size. What is expansive part takes as an input? The expansive part receives compressed high level feature maps from the bottleneck. Then it will start its upsampling. It upsampling the feature maps to increase their spatial size. Something like we can say about zooming out to restore the original image. It uses feature mapping via skip connections, and the convocational layer also refine the feature maps and make them more meaningful for segmentation. Now, the final layer. What is the final layer do? The final layer mainly does the rest of the works. It outputs a segmentation map where each pixel in the image is classified into specific categories such as tumor, organ, brain hemorrhage, background. Now, we will talk about the whole unit architecture. The unit architecture will, if we summarize, it is mainly a one-on-one convolution followed by a softmax activation or sigmoid activation. It is takes as an input and then pre-process it in encoder part. Then the bottleneck layer ensures it is reaching to the output layer perfectly, and the decoder part will merge the image and do give us the output. Now, why we are using this part or this unit? Because it is give us some advantages such as it is flexible and we can use any rational image for this job, and unit is very much give us high accuracy. It doesn't contain any fully connected layers. It has separate convolutional layers, and also it is faster than sliding window. Basically, also especially in medical image analysis, unit is regarded as the best till the humankind have ever seen. But unlike all these advantages, there is some disadvantage also, such as unit requires high computational requirements. Sometimes it takes significant amount of time because as it is not fully connected, it has so many layers. That's why it takes more time than any other any other architecture. Uh, as it needs to overfit and upsampling the data set. Sometimes in a small data set, it is tough to overfitting. Also, sometimes limited generalization to complex images. That's all from me. Thank you everyone. If you have any question or query, you can ask via email. Thank you, everyone.